So in this question, we are given that mod z minus 4 minus 5i smaller equals to 4 and imaginary z smaller equals to greater equals to 6. So find the greatest value of the argument of z minus 4 plus 2i. Okay, so first let us try to interpret what is where are the possible locations of z first. So this thing tells us that the distance between z and a particular value is smaller or equals to 4. Let's say we should rewrite this in this form. So we factorize out the negative 1 and this 4 plus 5i. So this essentially means that the value of z minus the distance of the point z, right, from the point 4 plus 5i is smaller or equals to 4. Right, then let's trace out. You have to play this do this math like playing a detective question. Z is the thief and he's moving around in the imaginary and the real space, the complex space, right? Argon diagram, he's moving around. And then this is a clue telling us where is the thief. It's telling us that the thief is away from the coordinate 4, 5 by a distance smaller or equals to 4. So the thief can be anywhere within this circle area. So he could be anywhere, because the reason is, okay, distance of smaller or equals to 4 means, okay, here this is the value 1. So if this is 5, then the furthest he can go, the thief can go is 1, or anywhere in between, right? So you know that in a circle all the radius are the same distance, so you should trace out the same distance throughout. It will be a circle. So the thief could be anywhere on the circumference of the circle or within it, right? Because it's smaller or equals to 4. If it's greater than 4, then the thief is outside the area of this circle. It means it's outside of this circle. The thief could be running here. But now it's smaller or equals to 4, so it's within this coordinate 4, 5 that we have, right? So the thief is within here. Then we see they also give us another clue. That means the imaginary part of z is greater or equals to 6. So this is the imaginary axis. So they're saying that the thief must be imaginary z of the thief must be greater or equals to 6. That means the thief could be anywhere here above the line imaginary z equals to 6, right? Above this line here, anywhere, the thief must be anywhere there. So combined with the first clue, then we know that the thief must be anywhere within this black color region. So combine these two clues together, we know that the thief is within this black color region. It's not below the 6 because it's greater or equals to 6, and because imaginary z is greater or equals to 6, so the y value, right, must be greater than 6. And smaller or equals to 4, it must be in this area. Therefore, combining two clues, the thief is running within this black color area. So now they ask us what is the greatest value of the angle, right, that the z makes with the point. Again, I factorize out, right? I factorize out the minus 1, and I get these two are equivalent. It's equal because I'm just taking minus out. So then the 4 minus 2i. So that means the angle that we are trying to find, right, could be this, right? If the thief is, for example, if the thief happens to be here, then the angle that the thief makes with the point 4 minus 2i, which is 4 minus 2 coordinate, right, that the angle would be this yellow color angle, okay, if the thief is here. But that doesn't give me the greatest angle possible. Alright, the thief could also be on this point, then the angle would be this blue angle, or the thief could be at other points. But we want the greatest value of this argument. Alright, so the greatest value happens when the thief is here. By observation, you know that the angle happens when it is this red color angle. That means the greatest value is this red color angle when the thief is here, right? The thief cannot be anywhere else. Okay, so if the thief is here, it doesn't give you the greatest angle. This angle is smaller than the red angle. Alright, any angle is smaller than the red angle if the thief is in the black color region. So so in the question asks us what's the greatest value. We have to find the value of the red color angle, right? So then the rest is just geometry. Okay, we have to find what is the red color. We focus our effort on finding the red color angle. So before we come to that, of course we have to do like what we have mentioned just now, all the work of interpreting these statements correctly, right? What it means, and also what it means to be of this. So critical method is convert it into this form where it's z minus the entire thing, alright? And all for the same for everything here, also convert it to z minus the entire thing, right? Into this form. Then we draw the coordinate, then we make the angle, and so on and so forth. Then we can find. So this part is the critical part. After we identify the angle that we find, is geometry, is something that we learn in the secondary school, is easier. So then, okay, so arc z minus 4 minus 2i, so therefore we have to draw this angle and then draw a positive x-axis line or at that. Then after that, we try to join to a point of z, any possible point of z, right, to find that angle. So in this case we want greatest value, so if we want the smallest value, then we use this point, then we find this blue color angle. Alright, so then let's think of how to find this red color angle. Okay, to find the red color angle, of course, I think we have to make use of geometry. So firstly, we need to know what is this coordinate. If you don't even know what this coordinate, it's impossible to find the angle, because let's say for example this one, we know this is 90 degree. Okay, if we draw a vertical line, it's also definitely perpendicular to the horizontal line, right? Okay, so then this is 90 degrees, so we can find this angle, this orange color angle. If we are able to find this orange color angle, then we take 180 degrees minus the orange color angle, we'll get the red color angle that we want. Alright, so one thing we know about this vertical line is definitely because this line falls, this point falls on the y equals to 6, or imaginary equals to 6. Therefore this vertical distance would be 6 minus 2, so it's 8. The distance here is 6 from 0 to 6, 6 plus another 2 here, so it's 8. The distance is 8. So we just need to find another side. Then we can use the tangent to obtain the theta, right? Because tangent is opposite over adjacent in a right angle triangle, right? So but we don't know what is this the x coordinate of this, so we can't find this. If we know the x coordinate of this, we just need to take 4 minus the x coordinate of this, and then we will get this distance, but we don't know, so we have to find that, right? Then how to find? So given that imaginary z greater or equals to 6, alright, so at this point imaginary z is exactly equals to 6, so as a imaginary z at this point is exactly equals to 6. Alright, and let's call this point z1 for convenience sake. Then we will distinguish from the z in the question. Right, then z1 minus 4 minus 5i equals to 4 at this point, because it rests on the circumference of the circle. That means its distance to that point 4, 5 is 4 exactly. Okay, so then we have this clue. Alright, then z1 can be expressed as, okay, let's x be the real part of z. That means z can be expressed as x plus yi. In this case, our y would be 6, so x plus 6i. Right, so because we want to find what is the x coordinate of this z1, right? So x plus 6i, we know that is 6. So then after that, minus 4 minus 5i must satisfy equals to 4. So this is like doing a simultaneous equation between this and this. Right, if you are not comfortable with, you are more comfortable with this, so you can write y equals to 6, and then this one would be x minus x plus yi minus 4 minus 5i equals to 4, and then solve the simultaneous equation. It will work as well, but I'm doing this, so I've already substituted 6 inside, and then after that, right, what is this, right? So remember, when you mod z, right, it's just equals to your x square plus y square square root. Okay, so because mod z is z, if z is here, then it's equals to s plus yi, right? Then this would be the distance x, this would be the distance y. So mod z is just the distance of z from 0, right, which is this distance, right, which is equals, using Pythagoras theorem, it would be x square plus y square square root. Right, that's how we derive this. So we just take x. Okay, in this case our x is x minus 4, the real part of whatever is inside this modulus, right? Let's take this entire thing to be a complex number by itself, and then the mod of this complex number is real part is x minus 4, then we square, and using the imaginary part, 6 minus 5 is 1, so 1 square, which is x square plus y square. Okay, so square root, then we get equals to 4 here. So we try to solve this equation. So then we square the 4, we got 16, then we bring the 1 over, okay, become minus 1, so 16 minus 1 get 15, and x minus 4 to the power of 2. So then after that we square root. When we square root, must remember to put the plus minus, okay, root 15, then I add this minus 4, I bring over, becomes plus 4. So why is there two solutions? Because actually satisfying these two equations, there are 2 points. One is this, and the other one is this. Of course, we don't need this at the moment because we are not finding the smallest value, we are finding the greatest value. Therefore, we use the x 4 minus root 15, because this is definitely 4 plus root 15, this is 4 minus root 15. Okay, so if this is 4 minus root 15, then the distance, okay, then tangent theta equals to, tangent theta is this angle here, right? Tangent theta equals to the vertical distance 6 minus minus 2, which is 8, okay, and the horizontal distance is 4 minus the x coordinate here. X coordinate here is 4 minus root 15, as we have found earlier, and then the distance is just, we know that it's just root 15, right? So we just the opposite side over the adjacent side, opposite side. Alright, so opposite side over adjacent side is 8 over root 15, so then we tangent inverse, we'll get this angle. Alright, we'll get this theta. Right, but the greatest value is not theta. The greatest value is the angle, this angle in red, right, is 180 degrees, which is the angles on the straight line, minus the theta, and that will give me the greatest value of z minus 4 plus 2i. And then you can use the calculator to calculate this value. Remember to switch to degree mode, not radian mode, because I'm using 180 degrees, not pi, right? So then we will be able to find. But then, okay, for complex numbers, we always want to express the argument in terms of pi. So no, we don't use the degree. Instead, we use the pi. So switch the calculator to radian mode when you calculate this value. Okay, and then you'll get an angle, right? The angle, when measured by the positive x-axis in the anti-clockwise direction, should be a positive angle. So that's it for this tutorial. And maybe I just calculate the value so that you could check the answer. Pi, right? That will take a while, but you can end the tutorial now if you want to. Mode radian, so nothing much, I'm just calculating the value. Minus tangent inverse 8 divided by root 15, and I get 2.02 radians.